So probability is very important chapter for UPSC India. Great many number of questions have been asked from this chapter continuously in all the exams. And this chapter requires, there's a prerequisite for solving the questions of probability, is that you must understand the previous chapter, which was permutations and combinations. Okay. So before starting, do anyone have any question, doubt from previous chapter or previous class?
No, sir.
Okay. So in this chapter, we are going to talk about experiments or events, if I were to be specific, events. Any event happening in your life having certain outcomes. Like if we kick a football, then it have lot number of outcomes, possible outcomes. There are possible outcomes. And if I list all the possible outcomes and make a set of them, a set of all possible outcomes, then it will be known as a set of all possible outcomes. That will be known as the sample space. Is that clear, everyone? Any thoughts, questions?
No, sir.
Let's now discuss some examples then, if it is clear. Let's take an event of tossing a coin. What could be the outcome of tossing a coin? How many outcomes can be there if you toss a coin?
Two, sir.
Okay, there are two. And which are they?
Head and tail.
Heads or a tails? Right. So there are two possible outcomes. If we write all the possible outcomes in a set, then that particular set becomes the sample space of an event. Okay, sample space of an event. So we are continuously improving our definition. Sample space of an event. The event was tossing a coin. Let's now talk about tossing a coin a little more because we are going to look at this uh, repetitively in multiple questions. If we go technically, then this particular element is one outcome, can be one outcome when we toss a coin. So technically, this will be known as sample point. And this too is a sample point. Now let's talk about tossing a coin a little more. Tossing a coin. How many outcomes were there? The sample space, heads or tails. Let's now discuss if two friends toss two coins simultaneously. Okay. To write simultaneously because I don't know spelling. Okay. Tossing two coins. The sample space can be on a particular. See, now we have two places occurring, like an event of tossing two coins. Here it can be head or tail, or here also head or tail with the second coin. This is the case of first coin or second coin. So how many choices? Two choices here and two choices here. They are they are dependent events. Why they are dependent events? Because the outcome of two coins are depending on each other, because we are going to consider them, and there's a particular event of tossing two coins. That is why they are dependent, because we are going to look on each and every outcome. So 2 cross 2, there will be four elements, four total possibilities. If there are four possibilities, there will be four sample points, or there will be four elements in the sample space set. So let's say there's a head on the first coin and head also on the second coin. It may happen, yes. Or head on the first coin, or it may be tails on the second. It may be like that also. Key there is tails on the first coin with heads on the second, or tails on the first and tails on the second. There's no other possibility that can happen because we have calculated earlier. So is this thing clear, everyone, that how we are tossing two coins and making a sample space of basically a set of all the possible outcomes can be there, that can be there?
Yes, sir.
Great. So this is about tossing two coins. Okay. What if we toss four coins? So if we toss four coins simultaneously, we'll have four results. So we'll have to use four places. For every place, there is two possible outcome. For tossing first coin, there is two possible outcomes. For the second, also two possible outcomes. Same for the all four coins. They are all dependent events because we are going to look on the result of all the four coins. Okay. So how many total? 2 into 2 into 2, 2 raised power 4 is equals to 16 total possible number of all possible outcomes. Okay. Are you missing something? Yes. We have gone to discuss the four coins cases first. Okay. Anyways, let's continue the same. There are 16 possibilities for this. So it's hard to list 16 possibilities, right? But we have got an idea, a hang of it. There can be head, or tail, or mix of them, or tail. Anything can happen 16 number of times. That will be our sample space. Is that clear, everyone, that how we have find it out the total number of all possible outcomes? Yes? No?
Yes, sir.
Okay. So let's not miss any case. Let's also discuss about tossing three coins simultaneously. What we are doing is tossing only, not playing any game. Okay. Okay. Yes. Tossing three coins. Three coins. So there will be three coins tossed. There will be three likely outcomes with every coin getting tossed. Two possible outcome for every coin. How many total number of possibilities in this case? 2 into 2 into
Uh,
2 makes
8,
it
sir.
8. Yes. Or should we say 2 raised to power 3, which is 8. This representation is important. We'll discuss it later. So now to list all these 8 possibilities, there is a trick you can use. So you have got to write H, H 4 times, then T for tails, Now go write h two times and then tail two times, then h two times and tail two times. Or now write head and tail, head and tail, head and tail, head and tail. Now you will get is the sample space of all 8 possible outcomes when you toss 3 coins. And the trick that I just taught you is really important, and it's going to help you in exam without thinking much. Should I write this or that? You have to make sure that you do not repeat any particular sample point. So that's why this is the trick important for you. Should I repeat or is it clear with the previous?
Now clear, sir.
Clear. Great. Great. So this is about all we have talked about tossing the coin. So before going ahead, let's get us as introduced to the probability. So probability is all about studying the likely outcomes to analyze the chances of certain outcome for an event. It's all that probability is that you study the likely outcomes so that you can analyze the chances of certain outcomes for an event. Okay, how exactly do you do that? So probability lies between 1 where 1 is included and 0 where 0 is also included. When we say probability is 0, I'm going to write PE for probability of an event E. Okay, so when I write P of E is becoming 0, that means it is an impossible event. Impossible event means that it is never going to happen. It is an impossible event which can never happen. And when I write probability is 1, then it mentions, it depicts that this is a certain event which is definitely going to happen. That the probability of me teaching this class till 9 p.m. is 1. Let's assume that it is 1 and it's a certain event that I am going to teach for sure. In spite of the, okay. In spite of the fact that in real life there is no impossible and certain event, but in mathematics there are, and that is the beauty of mathematics. It's not like chemistry or physics where you have to approximate something, and in chemistry where you have to ignore your own principles. Mathematics is a subject for ideals who follow principles. Anyways, those ideals go away when you go to a graduation. Okay, we got to stop kidding now and focus back on the topic. So my point was, for any impossible event that is not going to happen for sure, its probability will be 0, and for any event that is for sure going to happen 100%, that will be 1. 0 to 1, that's a scale of probability. Okay. We may also write, when we write 100%, it means 100%, which is 100. That means 1. 100% is 1. 0% is 0. So we may also represent probability in terms of percentage, but mostly we'll do it in between 0 and 1. Is that clear, everyone?
Yes, sir.
Better. So now we are going to discuss how exactly we can find out probability, like this 0 or 1, how exactly. So the probability of any event is the ratio of number of cases, number of favorable cases that we want to happen to the total number of cases. Okay, so probability of anything is number of favorable outcomes probability of any event is number of favorable outcomes to total number of, should write, number of all possible outcomes. Okay. Number of all possible outcomes is basically the cardinality of sample set. How many number of elements are there in sample set, sample space, sorry. And number of favorable outcome is that particular event's result that we wanted and how many times in a sample space it is occurring. Let's take an example back, go back and let's calculate the probability. When we were tossing two coins, let us say if we wanted uh, our uh, our desirable event was to get head on first coin when we were tossing two. Now the probability of our desirable event, which let's call it X. So the probability of X event will be the total number of elements that are there in the sample space, which are 4, right? And how many times head is there on the first coin? Here, here, not here, not here. Exactly 2 times. So 2 are the number of favorable outcomes that we want in sample space. So the probability of our event X, that is our desirable event, is 1 by 2, 0.5. Is that clear, everyone, that how probability is calculated?
Yes, sir.
Okay, so let's take one more event here itself, or let's take example from when we were tossing two coins. Let's say if we have the same event, we want we have the same event X when we wanted head on the first coin. So how many heads are on the first coin? One, two, three, four. Not here, not here, not there, not here. So four is the number of favorable outcomes. And how many total outcomes are there? How many total elements are there in the sample space? 8. So here also the probability is 1 by 2 for our X event. Let's take one more event, Y. When there is tails on second coin and heads on third coin. This is our event, very specific. So we have to check all those cases where we had tails on the second coin and head on the third coin. Very specific. Oh my God. So probability of event Y should be sample space number of elements are 8, same. How many heads on the how many tails on the second? 1, 2, 3, 4. Okay. How many heads on the third coin? in the same coin, in the same case, we need it to happen in the same time. Let me first remove the distraction for your understanding. Now better. So we want tail on the second. Okay, tail is there on the second and head on the third. Okay, this is a desirable case. Tail on the second, but there's no head on the third. Okay, we'll leave it. Tail on second, no tail on second. Tail on second, yes. Head on third. Okay, one more desirable event. Tail on second, head on third. No. So only two desirable events are there. Favorable events that we call 1 by 4. That is 0.25 is our probability. Is that clear, everyone?
Yes,
Is
sir.
everyone clear with the application of formula? Great. So let's go back to the formula. This is probability of an event. Now, if we had to find out, this was the basically uh, probability of occurrence of event E. Okay, but what if we have to find out the probability of event E not happening? We have to exclude. What if we have to exclude event E? Then what is the formula? We are simply going to apply some old tactics that we learned in the sets where we find out the complement. Non-occurrence or not occurrence. What should I write? Non-occurrence. Probability of non-occurrence of event E will be given by probability of E bar because it's known occurrence, like same we did with matrices transpose, or when we talk about complement set in the sets, here we will talk about non-occurrence of an event that will be given by 1 minus of probability of E. Is that clear? This is the probability of an event not happening. Okay, so let's apply it to understand it. Going back to the case of our tossing two coins. So now this time, the X event, we want the find out the probability of not X event, like X event not happening when there should not be head in the first coin. So what we'll simply do, we'll take one and subtract it from the probability of it happening. Okay, 1 minus half, that is half itself, 0.5. That is the probability when there will be no head in the first coin. Let's cross check. When there will be no head in the first coin, no, this is not the desirable, this is not desirable, this is desirable, this is desirable. How many total cases? Two favorable. How many total likely outcomes? Four. So its probability is also half, 0.5, which is same to the formula that we just used. Is that clear, everyone?
Yes, sir.
Yeah, better. Now, let's discuss about why event also. Why event was basically when there is tails on second, and we don't care about y. What if we have p of y? If you have to find out p of y not, 1 minus p of y simply. Let me save the file. Yes. So we were discussing about probability of y not happening. That is simply probability of 1 minus p of y, which was 0.25, which gives us 0.75 as our answer. So the probability when we will not have tails on second coin and heads on third coin is 0.75 driven by this one. Let's cross check. Now, y of naught is an event when tails is not there on the second coin. We don't care about the first, and heads is not there on the second coin. We have to make sure that this is not the condition. Okay, this is not the condition here. This is not the condition here. And yes, this is the condition. So we are not going to consider this for our case right now. This is TT on the last. So, okay, that's fine. HH on the last. Okay, that's fine. HT on the last. We have an objection, TH being on the last two cases. That's also not an objection. Objection for is TH here is on the second last two outcomes, which is not desirable for us. And here also TT, which is okay for us. So how many cases? 1, 2, 3, 4, 5, 6. 6 desirable and total 8, which is 3 by 4, which is 0.75. What has happened? Okay, 6 by 8, 3 by 4 after getting divided by 2, that becomes 0.75. And that is the probability which we earlier got with the same formula. Is the formula clear to everyone? Is the working clear to everyone?
Yes, sir.
Okay, great. So let's now, after discussing about probability, and we discuss probability being 0.5 sometimes. Okay, so when probability is so for two events when sometimes probability was becoming equal, so there are some events which are called equally likely events. With two or more points in the sample space. Let me write sample points. When two or more sample points are having equal probability, and if none of them is based on other or biased on other, it's not it doesn't care about the other event, the event, basically the result of occurrence of any event result with outcome. let's say uh, let's say about tossing a coin, right? We're discussing about tossing a coin. First, let me fix the color scheme. We were discussing about tossing a coin. So how many outcomes were there? Head or tail? And they are equally likely events. Head can come or tail can come because they have same probability. Why? Probability of head coming is 1 upon 2 because it's one desirable event out of 2. And that is the same for tails also. So we can call them equally likely event. Let's say if there is a bag, okay, and it have three balls of different color. Let's say red, green, and blue. Sample space, red, green, and blue. Now all these events, when red ball was coming out, if we take our hand and without seeing take out any ball, so all the balls will have same chance of coming, right? All of them have same chances to come out. So red, green, and blue all have same probability. So that's when we call it equally likely events. Is that clear, everyone? Clear? And let me tell you, probability is a chapter dependent on permutation and combination, and one more chapter, sets. So you need to remember all the concepts from the chapter sets as well. Let's now discuss some concepts which we studied in sets chapter. This word that I have written here is very important for you. It's going to play important role in questions. Mutually exclusive events. Do anyone of you remember what is a mutually exclusive event or a set? No one? Okay. So basically, mutually exclusive event is when uh, sets are when two sets are exclusive. Exclusive means they are very exclusive of both of them mutually. So the intersection, there is nothing in commonality in between those two. So there is no intersection of both of those two sets. That means here in the case of events, those events sample space are A and B, and they don't have anything common in them. In a random
So,
experiment, yes, yes,
sir,
Yadin.
could you excuse for 2 minutes? I'll be back.
Okay, sure.
Yeah, thank you, sir.
I think it's already 9. Shall we conclude the class?